Envision looking up and seeing a dawn so vast it fills half the sky. Neil deGrasse Tyson recently revealed that the red supergiant star, Betelgeuse, has undergone dramatic changes, sparking speculation about its impending supernova. Betelgeuse, a colossal star located just 650 light-years away in the constellation Orion, has captivated astronomers and stargazers alike with its unpredictable brightness variations. Betelgeuse, a red supergiant of cosmic significance. Home to over 200 billion stars, our Milky Way galaxy is vast and mysterious, yet Betelgeuse stands out as one of the brightest and most intriguing stars in our observable universe. Positioned on Orion's left shoulder, Betelgeuse's reddish hue and immense size make it a prominent celestial feature. If placed at the center of our solar system, its surface would extend beyond Jupiter's orbit, dwarfing our Sun. Despite being only about 10 million years old, a fraction of our Sun's age, Betelgeuse has already burned through its hydrogen fuel. Currently in the late stages of its life, the star is fusing helium into carbon, a precursor to the dramatic end of its life cycle. This makes Betelgeuse a critical subject for studying the life and death of massive stars. The unprecedented dimming of Betelgeuse. For years, astronomers have observed Betelgeuse's brightness waxing and waning in a regular 400-day cycle. However, in December 2019, something extraordinary occurred. Betelgeuse dimmed by an astonishing 50%, an event now known as the Great Dimming. This unexpected decrease in luminosity led scientists to speculate that the star might be on the brink of a supernova. The Great Dimming was later attributed to a massive outflow of material from Betelgeuse's interior, which created a dust cloud that temporarily obscured its light. Even after the dust dissipated, Betelgeuse's behavior remained unusual. Its brightness cycle shortened to 200 days, and by 2023, the star had become unexpectedly brighter at its peak luminosity. These anomalies have fueled the belief among scientists that Betelgeuse is nearing the end of its life. The path to a supernova. Massive stars like Betelgeuse undergo a series of intense processes in their final stages. After exhausting helium in their cores, they begin fusing heavier elements like carbon, oxygen, and eventually silicon. This process continues until the core becomes iron-rich. Unlike lighter elements, the fusion of iron absorbs energy instead of releasing it, causing the core to collapse under its own gravity. This collapse triggers a supernova explosion. When Betelgeuse explodes, it will briefly outshine entire galaxies, producing a dazzling light show visible even during the day. At its peak, the explosion could emit as much light as a full moon, offering humanity a once-in-a-lifetime spectacle. Due to its proximity to Earth, this cosmic event will provide invaluable data for scientists, offering insights into the life cycles of massive stars. Unique observations of Betelgeuse. Betelgeuse is one of the few stars that can be closely studied with advanced telescopes, both on Earth and in space. Unlike most stars, which appear as mere points of light, Betelgeuse's massive size allows instruments like the Hubble Space Telescope and radio telescopes to capture detailed images of its surface. These observations reveal a dynamic and irregular star, with massive plumes of hot gas rising and falling in a turbulent dance. In late 2019, telescopes detected significant disturbances on Betelgeuse's surface. The star's photosphere, its outer layer emitting light, showed uneven brightness and a notable decrease in surface temperature by about 80 Kelvin. These changes, combined with the formation of a mysterious dark region in its southern hemisphere, further deepened the intrigue surrounding Betelgeuse's fate. What lies ahead for Betelgeuse? The exact timing of Betelgeuse's supernova remains uncertain. Predictions vary, with some suggesting it could happen within our lifetime, while others believe it may still be thousands of years away. Regardless, the ongoing changes in Betelgeuse's brightness and behavior are a clear indication that the star is in its final stages. When the supernova occurs, it will be an extraordinary event, not just for scientists but for everyone on Earth. The explosion will release a burst of neutrinos, subatomic particles that will be detectable by observatories worldwide, followed by a surge of high-energy photons. This brilliant display will be a testament to the immense forces at play in the universe. A cosmic reminder. Betelgeuse's impending transformation serves as a reminder of the dynamic and ever-changing nature of our universe. As one of the most studied and beloved stars in our night sky, its eventual supernova will mark the end of an era, providing an unparalleled opportunity to witness the power and beauty of stellar evolution. Whether it happens tomorrow or millennia from now, Betelgeuse's story continues to inspire awe and curiosity among scientists and stargazers alike. Ultimately, Betelgeuse, also spelled Betelgeuse, is expected to accumulate iron in its core. When this process reaches a critical stage, the core can no longer generate energy through fusion. This leads to a catastrophic collapse, triggering a supernova explosion. If Betelgeuse is indeed nearing this stage, it could mean we are on the verge of witnessing one of the most spectacular events in the universe: the death of a massive star. However, many scientists believe Betelgeuse is still in an earlier phase of its evolution. According to this perspective, the star may have several centuries left before exhausting its fuel and undergoing a supernova. This view is based on stellar evolution models that account for the complex processes occurring within Betelgeuse's core. These models suggest the star might still be burning helium, delaying its transformation into a supernova by millennia. Adding to the uncertainty, researchers at Harvard University have estimated that Betelgeuse's supernova could be tens of thousands to even 100,000 years in the future. They argue that the star is still in the helium-burning stage, a phase preceding the fusion of heavier elements such as carbon, neon, and oxygen. According to these scientists, Betelgeuse has not yet reached the critical point of iron accumulation required to trigger a supernova. Their prediction is grounded in current theoretical models and observational data, though these models carry inherent uncertainties. The debate over the timing of Betelgeuse's explosion underscores the complexities of stellar evolution. Massive stars like Betelgeuse undergo various transformations throughout their lifetimes, influenced by factors such as mass, composition, and internal dynamics. Predicting the exact timeline of these changes is challenging, particularly for a star as massive and variable as Betelgeuse. Recent observations have heightened interest in Betelgeuse. In December 2019, astronomers noticed a significant dimming of the star, with its brightness decreasing to just 40% of its normal level. This unusual event sparked widespread speculation about the star's future. Some scientists proposed that the dimming was caused by massive ejections of material from Betelgeuse's surface, creating dust clouds that temporarily obscured its light. Others suggested it might signal deeper changes within the star, potentially heralding its approach toward a supernova. Betelgeuse's proximity to Earth, at just 650 light-years away, makes it an especially compelling object of study. If the star were to go supernova, the explosion would be visible from Earth even during the day, shining as brightly as the full moon. This closeness allows astronomers to observe Betelgeuse in greater detail than many other stars, providing invaluable data to refine our understanding of stellar life cycles. Despite differing opinions, there is a consensus that Betelgeuse will eventually undergo a supernova. When it does, it will be a remarkable event, offering insights into the life and death of massive stars. The explosion will release an enormous amount of energy, briefly outshining entire galaxies. It will also produce a wealth of heavy elements, contributing to the cosmic abundance of these materials, which are essential for the formation of planets and life. In the meantime, astronomers continue to monitor Betelgeuse closely using a range of telescopes and instruments. Advances in technology and our understanding of stellar physics will hopefully yield more precise predictions about when the star will ultimately explode. Until then, Betelgeuse remains a source of fascination and mystery, a testament to the dynamic and ever-changing nature of the universe. The star's massive size and brightness remind us of the vastness of space and the universe. The study of Betelgeuse highlights humanity's relative insignificance in the grand scheme of things while inspiring awe at the universe's spectacular nature. As researchers delve deeper into the mysteries of Betelgeuse, new questions arise about its behavior and potential future. Recent observations have revealed intriguing phenomena. Betelgeuse's extreme dimming events, such as the one in December 2019, continue to puzzle astronomers. Some experts believe these fluctuations in brightness are linked to pulsations or disturbances in the star's outer layers, caused by complex interactions within its interior. These processes may lead to periodic changes in brightness, but their exact mechanisms remain unclear. Other scientists suggest external factors, such as massive material ejections from Betelgeuse's surface, might be responsible for its variability. These ejections could create dust clouds that temporarily obscure the star's light. While this hypothesis explains some dimming events, it does not fully account for the observed patterns of variability. Adding further complexity, Betelgeuse might be undergoing significant internal structural changes. Recent observations have detected surface phenomena, including darkened regions and fluctuations in surface temperature. These findings suggest the star's outer layers are highly dynamic, potentially influencing its future evolution. Despite these uncertainties, astronomers remain vigilant in monitoring Betelgeuse. Advanced telescopes and instruments continue to gather data to unravel its mysteries. By studying Betelgeuse in detail, scientists hope to gain insights into the processes shaping the lives of massive stars and the broader dynamics of the universe. As technology advances and our understanding of stellar physics evolves, we may eventually unlock the secrets of Betelgeuse and other enigmatic celestial objects. Until then, Betelgeuse will continue to captivate our imagination and inspire awe as we gaze upon its luminous presence in the night sky.